Talk about this is a cool picture, and I tried to draw it, and I was having enough trouble drawing it out with a pencil and paper rather than with my Mobi board. So I decided to just copy the picture from the book. So if one way that you can estimate, you can generate a sphere, and this is actually where the volume formula, you know that the volume of a sphere is 4/3 pi r cubed. Do you guys remember that? So we're going to use this to check our answer at the end. But I think either in a couple sections, when you get to the volume section, which we're not on yet, I think it comes later on in like chapter 7 or 8, but you actually generate a sphere by rotating this around an axis, right? If I spin this circle around, I end up getting a sphere that looks something like that, right? Did I start recording it? I did. Okay, and you can add up lots of little disks, they're called, and you can find out the exact volume of the sphere. And this formula comes from calculus by taking a circle and spinning it around the x-axis, okay? Or the y-axis, you also get a sphere, and then you can add up the pieces in a different way. But if you remember from geometry, probably from last year in pre-calc, the equation of a circle is x squared plus y squared equals r squared, right? Remember that? So in this case, this radius, if this goes from negative, it tells you, a sphere of radius 4, of r equals 4, sorry, using 10 midpoint cylinders. So when I spin this thing around the x-axis, I get a sphere. And one way that I could estimate the area is by cutting it up into little cylinders. Kind of like if you took a bologna or something and put it on the ham slicer, you'd get lots of little cylinders on the bologna slicer, whatever it's called. You get
They're like really small slices.
Yeah, you get really small slices. But that's basically what you do when you find the exact volume of something. Okay? And so each one of these cylinders, if I were to take one of these and put it sideways, I don't know if I could draw this very well. I'll try to do this bit. Each one of these cylinders, that's not that
Wait,
good.
why are we not plugging 4 into the volume
Into here?
equation?
Because we're using calculus to estimate. We don't know that formula yet. The calculus students. No, and the other thing is, you can not only can you find the volume of a sphere, but you can find the volume of something like if you were to take something shaped like that, right, Kyle? And if you were to spin this around the x-axis, okay, you would get something that looks, a kind of conical shape. What's so funny about this? It's like a bell or something, and maybe you want to find the volume of a shape that's spun around the x-axis, rather than just and that doesn't have a simple formula, And so all of this is, and it's theoretical too. But each one of these cylinders, if I cut this cylinder up, you remember that the volume of a cylinder is pi. Volume of a cylinder is pi r squared h. Remember that? Well, in this case, r, where this piece, we're going to assume that you know this equation. Okay, pi r squared h, and that could be found from calculus too. But all you're doing is find the area of a circle and multiplying by its width, right? So that's a little more obvious than the sphere. But so r in this case is going to be the height of one of these little cylinders, right? And in that case, that's given by solving for y in this equation where r squared is 16, right? Because the radius is 4. So the equation of this particular circle, or semicircle, is x squared plus y squared equals 16. So r in this case is equal to the square root of 16 minus x squared. And the height of one of these little cylinders is equal to delta x, which is the width of your interval. You understand that? Maybe? So, if I want to find the estimate the volume of this, it's going to be the volume of my sphere, or the volume of the sphere is about equal to pi times r squared, which is square root of 16 minus x squared squared, right? Times delta x. And what I'm going to do with that is I'm going to sum all those things up. See that? That symbol means the sum. Sum. This, they don't use this in your book. But if I want to find the volume of that sphere, I'm going to take all these little cylinders, right? The volume of one cylinder in terms of x is going to be pi times square root of 16 minus x squared times delta x. Yes? Caroline?
I thought the volume of the sphere was the 4/3 pi.
Yeah, that's the formula. But we're going to estimate the volume of the sphere using 10 cylinders, okay? By cutting it up into 10 cylinders.
Wait, so is this how they got the original equations? Like, is this how they...
Come up with the 4/3 pi r cubed. Yeah, they use calculus and they do the fundamental theorem, which you learn in section 6-4, and they spin that around. They take the integral of that, and that's what you end up. Yes, sir. Yeah. So we're going to do that. So what does this look like when you do it on your calculator? What it looks like is I'm going to. So when I square this, this becomes pi times 16 minus x squared, right? So I'm going to sum all these things up, and then at the end I'm going to multiply by my delta x. And so if I want to use midpoint rectangles, it looks like I'm going to put, so my width of my interval from here to here is what? -4 to 4, right? That's the point -4 to 4. So my interval is going to be, the interval is 8. I'm going to divide that by 10, okay? So my width of my interval is going to be 0.8. Yes? You understand why that is? Because I want 10 midpoint rectangles. Right?
Yeah.
Okay? So now I'm going to take this outside, put the 0.8 out here, because I want to multiply it by the width at the end. And that's like my delta x for each one. And then I'm going to start with f of, if my width of my interval is 0.8, and I want midpoint sums. So if I want to start, so this would be negative. So my first, if I start at -4, and my width is, my next point is going to be 0.8 away from there. It's going to be -3.2. Where is the midpoint between those two things? -3.6. You guys see where that comes from?
Yep. Wait,
Because-
3.6? Oh,
yep.
you're in the middle.
Because I'm starting at -4, but I'm going halfway. I'm going, if I take the average between -4 and -3.2, this scale is kind of messed up on here because this is going by ones, right? I messed it up on purpose, okay, to make it a little bit trickier. And so I want to start at -3.6. Then I'm going to go 0.8 away from there would be at -2.8, correct?
Wait, why do you go 0.8 now?
That's the width.
Because,
But you just went 0.6, 0.4. You just went
You
from.
found the mid.
yeah, but I'm using the midpoints, okay? So from so the next midpoint is going to be a full 0.8 away. You get that?
From the midpoint or from?
From the midpoint,
Oh, good.
right? So the next
Oh, okay, that
midpoint,
makes
so the
sense.
next midpoint
2 points?
is gonna, no, where's the next midpoint gonna be?
2.2.
No,
Negative 2.2.
2.2.
2.8.
Negative 2, because it's 0.8 away from there, right? And the next one is gonna be at negative 1.2. And the next one is gonna be at negative 0.4. Where's the next one gonna be? Positive 0.4. Okay? And so the hardest part is figuring out what numbers to plug in there. Okay? And then plus f of 1.2 plus f of 2 plus f of 2.8 plus f of 3.6, which makes sense because then you're 4 units away, 0.4 away from the end, right? So that would make sense because that would be the midpoint between 4 and 3.2 would be at 3.6 or 3. And so then you just plug all that junk into your oops. I'm okay. Okay. And then you plug into that all into your calculator and get the answer. Want me to show you how to do that?
Yes.
Yeah.
Okay. So
Where's the pi going?
where the pi is in the function, right? So that's f of, right? So I plug the pi into my original function. Then you go to your stat.
Isn't it that squared?
No, because it's pi r squared. So when you square the radius, squaring the square root takes that thing away.
Okay.
See?
Yeah.
Okay? So now I have this, I go to my list, I go to edit, and I put those numbers in. All right? You can put those numbers in, right? Let me just do this second part again because people don't know where to go from here, okay? I'm going to clear this list at the top, and I just go up to the top of the L2 after I clear it, and I go bars, y bars, function, y1, okay? And then I have to put in parentheses, and then I go second L1, which is above the 1 key, and then I hit enter, and it should put all those values in there. Okay? Got that? And then you, let me get rid of that.
So you do y1
What
times list
is your
one.
Y1 is my original equation, right? So Y1, well, not my original, is pi r squared. I could put the delta x right in there, the 0.8 right in there, but I don't want to do that because I kind of want to show you that you're multiplying each one of those y values by a certain x value. Yes, sir.
If you put 0.8 in there, then you just sum it up and that will give you your...
It would give you your answer, yeah.
Okay.
But I prefer not to do that because I want to show you that you're multiplying each height by that width.
Okay, but
0.8.
if you did it, you
You would still get the same
Okay.
answer.
Can we see your list real quick? See those numbers?
Okay.
9.5.
Okay. What?
Yeah.
What's wrong?
I got completely.
You got completely different answers. Because you have a different
Don't you
one.
have to
There's
put
no
the x
square
into
root.
your original equation too?
What?
Y1.
No.
I did.
Where's the x? No, but yeah, it's pi and then 16 minus x squared times.
And then you have
The delta x, I'm going to multiply by the delta x at the end. Okay? Okay, so then I go second quit. Okay? And I go second stat. And over here in math, there's this sum. If you forget where it is, you can always use the catalog and look it up. You go to the catalog and look it up. And so sum is there, and you want to sum your list 2. Okay? So that's second 2, and that will give you that sum. I'm not done yet because I didn't multiply by my width yet. Right? So I need to multiply by 0.8. Okay? And I get out 269.42. Okay? Just to show you if I did 4/3 pi r cubed, let's just do that. 4 divided by 3 times r, which was 4 raised to the third power, right? Times,
Put that in parentheses.
I don't think I do. Do I?
Yeah.
Let's just see what happens. Times pi, let's see what happens. Yeah, so notice that this is the volume using the formula. This is the volume using that estimate, which makes sense because you're kind of at an overestimate because the last, if I use, some of them are going outside of that, outside of the curve, right? So if I go back, right, it's gonna, because these are the curve actually goes like this, you're kind of getting a rough estimate. Get that? So that's how you do something like
I
that.
found the simplest way that you don't have to put into the X thing. You just do L2 or L1 when you do it in L2 thing.
Yeah.
Yeah. So cool.
Say that again.
It's just out.
I want to talk about the cardiac output thing, which I'm not too good at this cardiac. So this is the thing that we were talking about earlier, and I think you just need to know what to do. You just need to know what to do, how to do this type of problem. So I had this done before. I was having like dizzy spells and stuff, and they wanted to see if my heart was messing up, and so they see if you have like blocked arteries or something like that. And so what they do is they inject your heart with radioactive dye. Has anyone ever had that done, or your parents have had it done? But they can trace what the volume of blood your heart is pumping out. Okay, and so it takes a little bit of time to get this stuff into your bloodstream, and then this is the concentration over time of the dye in your heart, and you can see from the table that these are the values that you're getting out. Turns out that if you sum up the areas under this curve, okay, and you divide that into the amount of stuff being injected into your heart, which in this case was 5.6 milligrams. So this is the sum down here. This is the area under the curve. And as far as the units go and all that, they show you why this works. And I had a hard time following that. So just know that you take the area under the curve and you divide that into how much dye they put into your heart, and then you have to multiply by 60 because they want liters per minute, and they give this to you in seconds. And yeah, this is how you do 15. So just follow along with the example. But basically, the important thing here is that you know how to find the area of the curve, because this doesn't have this curve. Let me see if I can make this bigger. This curve doesn't have a specific function to go with it. So you can't just plug it into your calculator and figure out the answer. So this is more like something you might see like on an AP test or something like that. They'll say use midpoint rectangles to find the area under the curve. Okay, and that's kind of the important thing. And so since you know if you start from 5 and you go to 31, or they went to 27, it looks like, this would be 29 right here. So to find the areas in these rectangles, you have to add up these things kind of individually. So the midpoint rectangles, you would start at 6. You see that? And so f of 6 appears to be about what? 1.5, right? So you would take 1.5 plus, and the midpoint here at 8 appears to be about 6 point something, maybe 6.4 or something. 6.4 plus blah, 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 blah. And then you multiply that by the width of one of these rectangles, which is what? 2. okay? And that would give you the dye concentration times the time. I don't really know what that gives you, but if you take that quantity and you divide that into the number of liters that they of blood that they pump, not of blood, of dye that they put into you, that will tell you your cardiac volume per minute, right, or per second, and then you have to multiply that by 60. And so, but the important thing is here that you're able to find the area under a curve using midpoint rectangles without a formula, okay? Without a formula. So you're just adding up a bunch of heights and then multiplying by the width. And then a lot of times, like I've said, like a lot of times on an AP test, they'll give you something that looks like this, and they'll say, okay, approximate the area under the curve using midpoint rectangles or using left endpoint rectangles, or right, and they'll give you ugly looking intervals like this, so you're not, so you understand that you have to add up each one of those individual rectangles. So midpoint sum might look like this, and then this one, right? And then this one is pretty close to the actual area, and so on and so forth. And then they'll say, is this an overestimate, an underestimate? How much is it off by, and so on and so forth. Yes,
They give you a picture, or would you have?
they would give you a picture, or they might just give you a table of values.
And then you would just.
Yeah, and that would be like on the non-calculator portion of a test, you know, so you can't use a Riemann, this is called the Riemann sum when you're adding up rectangles. You can't use a Riemann sum program to do that.
So it's just the fact that you know what you're
Yeah, you know what you're doing. All right, so that's about it, I think. Your homework is a continuation of yesterday. If you didn't do number 15, I assigned it again. You don't have to do number 15 twice, okay? You just have to do it once. So page 274, notice I have 15 twice. So if you didn't do it last night, now you kind of know how to do it. It's just different numbers, the same problem that I just showed you. And then 16, 20, 24, 29, and 30. Isn't that nice and easy?
Yeah.
They're really not that bad, okay? And that's it. And remember, you heard it here on Mr. Leader's Leading Edge.